Welcome to Chapter 12. Here we study one of the most fundamental concepts of calculus. That is limits. All right, so let's start off with our introduction into limits. Chapter 12.1. What in the world is a limit? Here is our textbook definition. Limit of a function. Suppose a function f is defined for all x near a except possibly at a. If f of x is arbitrarily close to L, as close to L as we like for all x sufficiently close but not equal to a, we write the limit as x approaches a of f of x is equal to L. Notice that is the language that we use. The limit of f of x as x approaches a is equal to L. Makes a lot of sense, right? All right, very confusing. Let's break it down. What do limits tell us? Limits tell us about the behavior of a function, all right? All about the behavior of a function. What is the function doing? More specifically, they answer the question, what happens to the function values f of x as x gets closer and closer to a given number a? All right, so what happens to the function values? And when you guys read the word function values, we're talking about the y values. All right, what happens to the y values of the function? Notice f of x can be replaced with y as x gets closer and closer to a given number a, as x approaches a is what we say. If f of x becomes arbitrarily close to a unique number L, as x approaches a from either side, the limit of f of x as x approaches a is said to be L. All right, again, here's our notation. The limit of f of x as x approaches a is equal to L. This is saying what happens to the y values as x approaches a, as x gets closer and closer to some given number a. As we said, if f of x becomes arbitrarily close to a unique number L as x approaches a from either side, the limit of f of x as x approaches a is L. Let's see what this means graphically. Here I have a function f of x is equal to x cubed plus 1. Let's evaluate our first limit. Here we are asked to find the limit of f of x as x approaches 0. Well, what this is saying is what happens to the y values as the x values get closer and closer to 0. Well, notice I can travel along my curve, and as I travel along my curve and my x values get closer and closer to 0, what do the y values get closer and closer to? Well, as the x values get closer and closer to 0, the y values get closer and closer to 1. Therefore, the limit as x approaches 0 of f of x is equal to 1. Again, we have to answer the question, what happens to y as x approaches some number? Okay, what about the limit as x approaches negative 1? So if I'm traveling on my curve here and I'm getting closer and closer, my x values are getting closer and closer to negative 1. Same thing, traveling along my curve here, my x values are getting closer and closer to negative 1. What happens to the y values? Well, the y values are getting closer and closer to 0. Therefore, we say the limit as x approaches negative 1 of f of x is equal to 0. Again, what happens to the y values as x approaches some number? Let's look at one more. The limit as x approaches 1 of f of x. Well, I'm traveling along my curve. What happens as my x values get closer and closer and closer to 1? As my x values get closer and closer to 1, the y values get closer and closer to 2. Therefore, the limit of f of x as x approaches 1 is equal to 2. All right, couple things to make note of here. The existence or non-existence of f of x at x equals a has no impact on whether or not the limit of f of x as x approaches a exists. The existence or non-existence of f of x at x equals a. That means even if our function is undefined, we can still evaluate a limit, or we may still be able to evaluate a limit at that location. Let's take a look at another function here. f of x. And we notice that this function has two discontinuities. It has a discontinuity here at x equals 0. Notice we have a hole in the graph at 0, comma 2. And then we also have a discontinuity at x equals 3, right? The function, however, is actually defined at x equals 3. F of 3 would be equal to 1, right? But we still have this discontinuity. Well, let's evaluate a limit here. We are said, find the limit of f of x as x approaches 0. Again, limits tell us what happens to the y values as x gets closer and closer to, in this case, 0. Well, as my x values get closer and closer and closer to 0, what are the y values getting closer and closer to? Well, as the x values get closer and closer to 0, the y values are getting closer and closer to 2. Therefore, the limit as x approaches 0 of f of x is equal to 2. So even though our function is undefined at x equals 0, we can still evaluate the limit here. What about the limit as x approaches 3 of f of x? Again, limits tell us what happens to the y values as x gets closer and closer to 3. Well, as I get closer and closer to 3, my x values get closer and closer to 3. What are my y values getting closer and closer to? The y values are getting closer and closer to 3 as well. Therefore, the limit of f of x as x approaches 3 is equal to 3. In this case, f of 3 is equal to 1, right? That's denoted by this point right here. If I plug in 3 for x, I am going to get out 1 for y. F of 3 is equal to 1. The function values, however, approach 3 as the x values approach 3. The y values are still approaching 3 as my x values approach 3. Therefore, the limit is still 3. We also can evaluate what are known as one-sided limits. Okay, one-sided limits. Here's the notation. The limit of f of x as x approaches a, and this little plus sign denotes that we are coming from the right side of a. Similarly, we also have left-sided limits. The limit of f of x as x approaches a with a little minus sign up here means that we are evaluating the limit as we approach a from the left-hand side. Let's see if we can't put this to use again with some graphs. Use the graph of f of x to evaluate the following one-sided limit. The limit as x approaches negative 7 from the right. Well, here is our value negative 7 for x. As we come along this curve, as my x values approach negative 7 from the right, this plus sign again means from the right, the y values get closer and closer to 6. Therefore, the limit as x approaches negative 7 from the right of f of x is equal to 6. Here we have the limit as x approaches negative 5, and the little minus sign up here means from the left. Here I have x equals negative 5. As my x values get closer and closer to negative 5 from the left-hand side of negative 5, my y values get closer and closer to 0. Therefore, the limit as x approaches negative 5 from the left of f of x is equal to 0. The limit as x approaches negative 3 from the left of f of x. So here is x equals negative 3. As my x values on my curve get closer and closer to negative 3 from the left-hand side, what do the y values get closer and closer to? Well, the y values get closer and closer to negative 6. Therefore, our answer is negative 6. The limit as x approaches negative 3 from the right. Well, I'm on my curve and I'm approaching x values of negative 3 from the right-hand side. What are the y values approaching? Well, in this case, the y values are actually all equal to positive 1. Therefore, our answer is going to be positive 1. The limit as x approaches 2 from the left. Here I have x equals 2. If I'm coming from the left side of x equals 2, what are my y values approaching? Or what are they equal to in this case? They are all equal to 1. Therefore, our solution is going to be 1. The limit as x approaches 2 from the right. Well, again, here is x equals 2. If I'm traveling along my curve and approaching 2 from the right-hand side, What are the y values getting closer and closer to? They are getting closer and closer to 3. Therefore, our solution to that limit is going to be 3. A couple more here. The limit as x approaches 4 from the left. Here I have x equals 4. Well, as I travel along this curve, as my x values get closer and closer to 4 from the left-hand side, what are the y values getting closer and closer to? They are getting closer and closer to 6. Therefore, our answer is 6. And the limit as x approaches 4 from the right, again, I'm traveling along my curve. My x values are getting closer and closer to 4. From the right side of 4, what are the y values getting closer to? They are getting closer to 6. Therefore, our answer is 6. So there you have an introduction into limits. What do limits tell us? They tell us what happens to y as x approaches some given number.